All right, so we're going to start, and this week we're going to look critically at how to create a model if we have a requirement as a database administrator. The lessons for week 7 is majorly about altering tables. When you create a table, want to add new columns after or rename something or change things around, the pre-recorded videos are self-explanatory, and so we won't go into that topic, but we're going to look at how to insert record. We're going to look at transactions in a different way, and then we're going to look at assignment 4, and we'll walk through assignment 4. Now, when we want to insert a record into a database, let me just use a plain SQL sheet here. We use insert into statement like this, and then we provide the names of the column, values, and then the values we want in those columns. Now, when we provide values here, and we have something like a primary key, let's use the access control, for instance, and let's use this to illustrate this. So I will say use access control. And we want to insert into the table name users. And now we want to put all of the columns that we want to insert into. Since the user ID is an auto-increment column, we don't need to insert record into it. We just start with the username. We use the email, then the user password, and created that. So these are the columns that we have. And also created at has a default value of current timestamp, so I might not need to put it here. You can do that and put the record and put in the time, but you can leave it to just insert when the record is inserted. Now we want to have values for the username, the email, and the user password. Let me just have some random values. Let's say the username is and let's have the email to be and now we want to have the password. So let's leave it at this. Now I have this insert statement to insert into the users table. My columns are user ID, username, email, user password, and created at. User ID is set to auto increment, and so it automatically inserts from the last insert ID. Created at is set to have a default value of the current timestamp, and so I don't need to put those columns and those values. So I'm going to run this, and then we have a problem: duplicate entry, MIDI 986 for key, and 0 row affected. And the reason is I've inserted this same value previously. So what I'll do now is to comment this out. I want to use this to illustrate. So that's why I want this error to happen. So I hope you can see the error here. Insert into users, this, and then it says duplicate entry for the username, because we want the username to be unique based on the definitions we did in the last live class that we had. But let's select all from users. And we have that record inserted with the timestamp inserted just now, because I clicked it twice, right? Now, how do we solve this problem of having an error? We use insert ignore instead of insert. So I'm going to uncomment this. And here when we put insert ignore into users. So in the event that one unique value already exists, it's not going to stop your application or going to crash the system. It just automatically bypasses it and says something like 0 row inserted, it sees that this already exists. So what insert ignore does is just like create table if not exist. Insert it if it has no conflict, or the primary key does not exist, or one of the unique value does not exist there. And if it does, just ignore it. So that's this statement, insert ignore. And so now when I run this now, you won't see any error. It will just tell us that 0 rows affected. Here, 1 warning. So here you get a warning, and you can turn off warnings or whatever it will, and this will not stop your system or fail the system. But when you use transactions, you don't want to use insert ignore. You just use insert directly, because when it's time to roll back, all this insert ignore, when it fails silently, it might become a problem. And so when you are using transaction, you want to just do insert into the table. And we're going to look at an example of transactions now in a way that makes more sense than the examples that we have in our notes. All right. Anybody has question now? Does everyone understand?
Yes.
Okay. Now, when we talk about transactions, we're talking about inserting record into multiple tables at a time. And all the inserts must succeed together, or they must fail together. So if one fails, you want to roll back. And this has applications in so many industries, especially in the banking industry. If you go to the ATM machine, or you go into the bank and you want to withdraw money from your account, the first thing it does is to check if you have that balance you want to withdraw. And so the very moment you are withdrawing the money and it's being given to you, it should be deducting from your account, or you want to transfer money to somebody. So you want to do 2 transactions. Your account has to be updated, and the other account that you're sending to has to have an insert going in there. And so because these 2 transactions must happen at the same time, so you don't want to transfer money to somebody, your account is deducted, the transaction fails, and the money is not deposited. And then that already breaks the integrity. So when you use transaction, it keeps to all of the ACID properties. And so all of the operations that must succeed together or that must fail together are all wrapped within a transaction statement. And that is what I want you to do in assignment 4. And let's look at assignment 4, because it can get a little complex to think about it. We have a form below here, and it's a form I downloaded from the internet for you to go through. What I want you to do in this assignment is to create, first of all, a document with your plan that will outline your database and the table plans that you have. Then, from this form, think about 6 different tables that you have for your database that will store all the information from this form. So the idea is that this form will be presented to the user as a single form. But when it is filled in and it is submitted, you want the data to go to different tables in a database, right? And then I want you to have at least 6 tables for it. And all the tables must be linked and connected. So you don't want the first table to have a particular information and repeats that information in the second table. Whatever information exists in the parent table should just be like a foreign key in the child table. So you insert record into the table using transactions, and then the grading rubric is there. But let's look at what the form is saying, and let's do a walkthrough. I'll create like 2 tables on a database, and then I'll do the transaction between the 2 tables, and then you apply the same thought process towards the whole assignment. Now, this form has an identification part. Now, this gives you an idea for a table. You can say, in this form, I want to have a table called patient identification, or whatever name you want to give. And this particular table will hold all the personal information of the patient. So we see the fields for the form. Now, when you work as a database administrator or as a back-end developer and you work with the front-end developers, they are going to build the front-end, the field, and the information that is collected on the front end needs to be processed somewhere by the scripting file. and sent to the database table. And this table must hold the columns where each of this information that is collected will go to. Now, if you are a database administrator, not all columns of your database exist in the front end. Things like they created at timestamp, who created the documents, who updated, all those logs. Nobody controls it. You want it to be automatically stamped by the system. When the record was inserted, you want it stamped. When the record was updated, you want it. And then the person who is logged in and did that, you want it to stamp the name of the logged in user as the created by or updated by record. So these are not records that exist on the form, but they are things that you want to create as columns of your database table. Does everyone understand?
Yes.
Okay. So you now have an idea for a table. The first one, identification, where we collect this information, and you have an idea of the things that does not exist on the form that has to be on the table. Then we have another one, chief concern. We have treatment history, we have relationships, and then we have educational history, and we have abuse history, we have chemical use, and other. When you create your tables, you don't have to make the tables each category. You can skim through the table. So the first thing you do is to look through all of the tables, all of the form fields, and then you look at information that are related. If you have, for instance, let's say I have information here that says, does the patient have, no, let's not use this. Let me use family history. Okay, so I have this information here that says relationship between adults in the home, patient relationship with each parent and with other adults present, right? And then here you have patient relationship, important friends past and present, and now patient relationship with their own children if present. There is another section that has to do with the kind of relationship that patient has that you can bring forward to add it to this section instead of going backwards, like instead of creating new columns. For instance, where they say chief concern here, and you come here to look at does patient have learning disability, learning disorder? This can leave this section for learning and be like a diagnosis for the chief concern. So it's you that will think about all of these things and then see what form field, what column names you want to have, because now you're doing the back end and the front end developer will have to look at this to inform how they build the forms on the front end. Now, because you have this form like this, doesn't mean that the front end developer will just recreate this form like this on the front end. They'll do it so that it relates to the work that they are doing. I don't know if you all understand.
Yeah.
Good. So now that we have that thought process, I'm going to create two tables. Let's say I'll do this identification part, and let's do the A and B and chief concern part. So that we can illustrate transactions on these two. So I'll switch back over here. So the first thing I want to do is to create a database. Or let's look at this carefully again. So I have this identification section that collects demographic information. I want to have columns like the name of the patient, the date of birth of the patient. I don't need to put age because date of birth and age doesn't make any sense. From the date of birth, we can always get the age. Now, if you put age, it's going to be static because every year it has to change, right? But when you use the date of birth and in your system, you dynamically calculate the age, it always calculates the current year. Once the person's new birthday is, the age changes automatically. So we don't need to put an age column. The date of birth is okay. And then we have the parent or guardian name, and then maybe we'll put this as patient is living with. So maybe we'll just say primary custody or something like that. And then marital status of the parent of the patient. We'll have that there. So let's do that. Okay. So I'll come here and I'm going to create a database first. So create database if not exist, and we're creating, let me name this database youth support like this. And I'm going to have the character set, the collation, and then I'm going to run this. So we'll have the database created. We want to use the database youth support. So I want to create a table, and I want this first table that I will be creating to be like my, let's see, to be like my registration table. So I'll call it patient registration. Let's go there. Hold on. Okay. So I'm going to make this patient registration. Anybody saying something? Okay. So we'll say create table, and let's use if not exist. And the name of this table will be patient reg. And then we'll put all of the column definitions here. So we want to have an ID column, just like an index, that we can easily have serial number. So say ID will be an int. We want it to auto increment. We want it to be the primary key. We want to have a created at column, and we want this to be a timestamp. We want it to be not null, and we want it to have a default value of current timestamp. Okay. Then we want to have the created by column, and this will be a varchar. Let's assume that all the names or identifiable information will be encrypted, so we need a lot of space. And then we'll say it's not null. Then we want to have the patient ID now, which is going to make this a primary table. Now, because we want to have several tables to hold the different related information from that form, we need to have a parent table, which is now going to be the registration. That parent table has the unique identifier for each patient, where you can easily get the records by just using that patient ID. And so if for any reason the patient ID changes on the parent table, then we want it to cascade down all of the tables. So we have that, keep the integrity of the data. So we want the patient ID to be, let's make it varchar just in case. Let's say it's to be 15, and we want this to be not null and unique. Now, I didn't make this the primary key because primary key actually is not null and unique by default, but I don't want it to be the primary key. You can make your patient ID the primary key if you choose to. All right, and then we have the date of birth. I'll use DOB, and I'll make this to be a date type. So I'll say date not null, and I want to have the information about the guardian. So patient is living with, so let's just say we'll just put it as guardian and then they will select. So if we want to have this predefined list, we can actually put an enum and list all of these things here for an enum, but I'll make it a free field just for the purpose here. All right, so we'll say let's name that guardian, and I'll say this is voucher, and let's make this voucher 200 for instance, and we'll make this also not known. Then we want to have the physical custody, so name of parent or guardian, and then we have who patient is living with as physical custody. All right. So you can give your column any name you want, just know what it relates to on the form. So that will be in your documentation as your question 1. So the physical custody, let's make it voucher 200, not known. And let's look at marital status of parents. We can decide to make this an enum and list of marital status, but if we have a fixed list, maybe it's going to be different and order. We can use that. So let's make it a free field. Voucher. And we'll say nothing. All right, and let's put the default for this one. The default will be not applicable. Okay, so now we have all of this, but when this record is updated, we also want to have who updated the record and at what time the record was updated. So let's use an updated at and updated by here. I just change this to updated at. So the processing script is the one that will control what is inserted in this column. If nothing is inserted, it will use the default current timestamp. Updated by the processing script to take the name of the logged in user and put it there, or the ID. All right, so we have this table that we want to create. So let's run this, see if all is well, and then we'll try to create the other table for the concerns. So I'm going to run this, and all is well. We have that table created. So let's look at this. We have the youth support, and then we have the patient registration. Okay. So now it's time for us to create the other table, which is the patient concern table. And this, we just have a space for the concern, but we know that we want to put the timestamp, the person who did the record, when it was updated, who updated it, and even maybe a date of the onset for that concern. So something like that. So let's create a table called patient concern. So create table, if not exist, patient concern. Okay, so now we can do the same thing and have an ID that is an integer that will be the primary key, and that will auto increment. Then we want to have the patient ID now. We want this patient ID and this patient ID to be related, and which makes this a child table. And we're going to make this a foreign key. So when we want to make it a foreign key, we have to have the same constraints. So we have varchar. Here, we will not make this unique here. Or we can actually make it unique if we want. But if we want a table that is not going to be overwritten, we want to just have the logs of the state of the record at each time, we will not make it unique. What we do sometimes is to have a patient concerns table and a patient concerns log table. The log table will take all the inserts of every time the record is changed, and the patient concerns table will just have the last inserted record for that patient. So when you load up the dashboard, the most recent information shows, so you don't have to sift through a database that have heavy information. When you now want to select the history, then maybe it now loads from the log table where you see all the history. So these are thought processes that you start having when you start going deeper into full stack development, seeing how the process works in real life and how you want to translate it into the software. Right? Does everyone understand?
Yeah.
Okay. So the patient ID here, we'll make it varchar 15 like the other. And I'll just make it not null, but I will make it unique. So requirements are very important. You have to read the requirements and see what your client wants or what you're asked to do. All right, so we'll have the patient ID. Maybe we should have a created at and created by first, then updated at and updated by. I'll just copy this to make it faster. And then we'll use this for updated by and updated at. And here, let's put the concerns or concern. And let's make this text, since it's going to be a field that will take a lot of stuff. Maybe make it as concerns, just in case. And then we'll say not known. We want to have something like maybe date of onset. And we want this to be a date type, and we want it to be not known. Okay. So we have these, and patient ID is a foreign key. So we want to specify that. So we'll say foreign key, and the foreign key here is patient ID. The references now will now be the patient read table. So references will be patient read. And in parentheses, the name of the column there is patient ID. And then what happens when the parent table is deleted? So we'll say on delete, we want it to cascade. And then when it's updated, we use on update. We want it to also cascade, which just means that when it's deleted, when the parent table is deleted, when the parent record is deleted, the child record should be deleted. And so you don't want to have any disjoint or any record that exists on one table and there is no root on another table. So once that record is deleted on the registration, the patient read table, you want it deleted on the patient concern. And if you don't want it, instead of cascade, you put restrict, right? You can put restrict there. You don't want it deleted. So it controls that this will not be deleted if the parent is deleted. Okay, so this is the definition we want to have. We want to have this patient concern having the created as created by patient ID. We want it to have the concerns, the date of onset, and updated as updated by, like this. And so we're going to run this, and all is well. We'll refresh this and we'll see that it is created here, patient concern. We'll look at the column, we have them. We'll look at the foreign keys, we have patient concern. Foreign key here is automatically named patient concern IBFK1. So if we don't name our foreign key, this is how it automatically names itself. Okay, so now that we have done this, we want to make sure that let's assume that this hypothetical form that I'm using to do this, I don't want to use this whole form because this is your assignment. But let's say my form only has the form the client is going to fill only has A and B here, identification and chief concern. And on that form, they'll fill these two things and click on the submit button on the front end. When they click on submit, you want both of them, the registration to happen and the concerns to be inserted along with the registration. You don't want the concern to be inserted and then the registration fail, and so there's no parent for the child. All right, so what do? We want to use transaction to insert this record. So I'm going to use transaction like this. Whenever you use transaction, you start by saying start transaction. Okay, what that alias is for start transaction is begin. So if I do transaction, you can do begin like this. Okay, then you want to start your insert statement. At the end of a transaction, you use commit. But see, if you look at stored procedures, or you do other ways of doing this where we can run a conditional statement to say if everything has gone well, commit, else you roll back. And this, we're going to do this in an advanced course, but if you can go on the YouTube channel, you'll see that we did that in a different advanced course, and the video is online if you want to see how to use the conditional statement in MySQL to do that. But here we'll do it basic. Right, so you start with begin and then you end with commit once you are done inserting everything. Okay, so by default, this already has auto commit set to true, so you can set it to false before you start. But I think your lesson notes contains that where transactions are always true, always on by default, and so everything is committed once you do it, except you set auto commit to turn it off or to set it to 0, your transaction will always commit. All right, so once to set auto commit is already on, but I just want to demonstrate this, so I will not bother doing that. We want to insert into the patient read table, and we want to insert into the patient concern table, and we want both of them to insert at the same time. So we want to say insert into. Now I'm not going to use insert ignore because I'm using transaction. Into patient read, and we're inserting into the created by, we're inserting into the patient ID, we're inserting into the date of birth, we're inserting into the guardian. Let me see that. Okay, and then we're inserting into the parent marital status. Let me check how I define this. Yeah. And we're also inserting into the updated by column. We have physical custody too. Okay, and then we'll have updated by. Okay, so we have all of these columns we want to insert into the values now. And the values we want to insert here, we'll start from the order in which we named the columns here. So you must put it in the order in which you listed the columns. If not, you'll be inserting the wrong information into the wrong column. So I want to say, let me just use my name as created by. I want to have the patient ID. Let me make the patient ID 1000, like that. And so in your application, you're not typing a raw value. It will be a variable that holds the value that the user has filled in. But we're putting raw value to test, right? And then let's say the date of birth of the patient. Let's put the type date. Let's say 2013 03 17, like that. And then let's say the guardian name. Let's put Agnes Brown. Then parent marital status, let's say married. Physical custody, let's put with grandmother. And then let's say updated by, I'll use my name. Okay. So we want this insert to happen along with another insert. Now, there is this other structure where you can set that key, that primary key. When you say set and you put at, let's say you want to set at patient ID. So you can set it here equal to 1000 or something. And then let's try this. Then we'll remove the set if it doesn't work out. Now you set it equal to the ID that is here, right? So because you want it to insert into it the same way. So let's say insert into. Now we're inserting into the other one, which is patient concern, right? So insert into patient concerns, and we want to insert into the columns ID. ID is auto increment, created at will automatically stamp, created by patient ID, date of birth. Oh no, this is for this one. We're going back to patient concern. So we're doing patient ID concerns, date of onset. So just 3 things we're supposed to insert. And okay, along with the created by. So let's say created by. We want to insert patient ID. We want to insert the date of onset. And we also want to insert the concerns. And we want to insert the updated, the updated by. Now the values will now be, so we want the created by, let me just use my name, the patient ID. Now we can use this at patient ID num for one. So normally we use this to just set, like if you want to have the last insert ID, and we use the last insert ID function here. But let's try it if it works with this. If not, we'll just revert and I'll show you how we use this. All right, so the patient ID will now take this ID to be the same with this. And this is more useful when you have several tables, like in your case for your assignment, you have over 6 tables, right? If you're inserting raw like this, but when you're inserting from a script, say you have a backend script that collects all of this information, they're all stored in a variable. So you're taking the variable names and inserting. You will need all of this, you just put the variable name there. Okay, so have the name of the person who created, the patient ID, the date of onset, let's say and then Let's get the concerns. Let's see. The depression, nightmares, panic attacks. Okay. And then let's look at the updated by, and I'll put my name. All right. And at the end of it all, we want this to commit if all is well. Okay. So let's see. I think I'm missing something. So we commit this if it's all well. So start transaction, we insert into the patient registration table, and then we set the patient ID norm and we insert into other tables. So if you have other tables to insert into, you keep inserting into. But you get the idea of not repeating information, just get the patient ID. Here you can also have the patient name as it is on the form, but I'm just doing an illustration, not the whole homework. So let's try to run this and see if we have any problem. So everything went well, it's committed at the end, and let's select all from patient reg and then select from the other one. So let me comment this out. And we'll have our inserted information there. We have the created at everything patient ID 1000. And then when we select from patient concerns, we have everything, the patient ID 1000. So you realize that in our patient concerns table, we did not have the patient ID listed, but we use this alias or this variable that we created when we set that ID to what this ID is here, patient ID is. And that's the same thing you do for the other tables down. So this is a more reasonable way of using transaction. When we do conditional statements in SQL in an advanced course, you'll see how we can now use the condition to commit and then another one to roll back, like you write roll back if everything does not insert together in the end. All right. Does anyone have any question?
No.
Does everyone understand this clearly?
Yes.
Everybody?
So far. It's clear so far.
Okay. All right. So this is the agenda we have for today. If we still have time, if anyone has any topic you want me to look at before we go, but if not, your lesson resource and the pre-recorded videos along with the previous videos you have already covers everything that we have. And another note again is that I'm going to repeat lesson week 4 lessons, and when I upload them, I'm going to let you know to include more details for you. All right, week 4 and week 5. I think week 5 and 6 were just in the live class. I'll try to get a comprehensive pre-recorded video to just give you a comprehensive detail of that topic. All right. So anyone, anything extra, any question? All right, so in the absence of questions, I'll share the video as soon as I receive it, and it will be in the classroom. All right. All right, everyone. Have a very good weekend and see you all next week.
Thank
Thank you.
Okay, man.